YouTube. Oh, good. Hi, Otto. How are you? So we're going to start section 1.4 today, but before I get started, I wanted to ask if anybody has any questions over their homework so far. So last week we didn't get super far. We did 1.1, right? And then in class on Monday, we did sections 1.2 and 1.3, which I think for most of you were review, right? In 1.2, we talked about simplifying expressions. So expressions are not equations. They don't have an equal sign in them, but we can simplify different ways. We can use the distributive property, right? We can use the power of exponents. We can use like terms to add similar terms together. So those are all ways to simplify simplify expressions because expressions don't have an equal sign. And then in 1.3, we talked about solving equations. So everybody seemed pretty confident in solving equations when we were doing some in class. We talked about the different solutions that are possible. But I did want to ask, and when you guys were trying your homework, were there any problems that you had questions on that you wanted to go over? Everything felt pretty good. Give me the thumbs up in the chat. You can tell me it was good. Okay. Well, I don't hear anybody saying that they had any issues with 1.2 and 1.3. So what we're going to do today is we're going to go over 1.4, which is a little bit trickier, not crazy tricky, but just a little bit trickier. And it's called rewriting formulas and equations. So that's what we're going to go over today. And if you have your notes, go ahead and grab them out. And I have my notes right here. So the first thing that I want to point out, and I was very lazy in my notes here, and I just said, check out the chart on page 26 of your book. Unfortunately, I don't have an online copy of my book, but if you have your book with you or nearby, on page 26 of your book is a chart of all of the standard formulas that we have for reference below. And actually, if you guys give me a minute, I might be able to. It's always scary to Google online, but let's see. This is a distance, temperature, area. So if you have your book, you can just pull this up. What I'm trying to do is find the chart so I don't have to recreate it. Angle, you can tell my awesome spelling skills here. Let's see if I can come up with a chart really quickly. Oh, this will do. This will do. So in your textbook, you have basically a chart, and it has a few more pieces of data than this, but it gives the standard formulas that we use a lot in mathematics, and we also use a lot in science. Ugh. I got to figure out how to make this chat pop out so I don't have to keep changing my screen. Anyway, so in your book, there's a chart like this. I just want to point it out. We're not going to do any homework problems related to this today, but there is a reference here on page 26. Like if you need to remember, okay, how do I convert Celsius to Fahrenheit? There's a formula that lets us do that, right? How do I convert, or how do I find the area of a triangle? Well, the area of a triangle is 1/2 base times height. So I do want to let you know that those references are there. When we get to each of these things, like when we do problems with area or perimeter or distance, we'll review that. But I just kind of wanted to point those out that they're introduced in this section. We're just not going to do problems with those exactly. We're going to actually focus on rewriting formulas and equations. Okay. But I wanted to point that out. So that's the first thing. So you have a chart in there if you'd like to look at that. Who's used these before? Like who's converted Celsius to Fahrenheit or Fahrenheit to Celsius? You've done it?
I have.
You have? Is it lots of fun? It's not too bad, right? It's just plug in the variable and find it, right? Awesome. Okay, so what we're going to be talking about today seems a little bit weird, but it's actually an important skill to have in algebra, and I'll explain why it is, why that is an important skill. And this is called rewriting formulas and equations. So what we're going to be talking about is if you have an equation like 9y minus 4x equals negative 31, okay? Oh, good, I can highlight it there. If you have this equation, I may ask you to rewrite that equation in terms of y equals something. So instead of writing it in this format, I want you to say y equals whatever it's going to be. We have to convert it to figure out what it might be. So there is a reason that this is important. Actually, there's two reasons that it's important. One is that, let me pull this up in Paint. One is kind of just a technical limitation, let me say. So any of you guys that have a TI graphing calculator, okay, so what I'm talking about is, let's take this equation and instead of writing it this way, let's write it as y equals something. And we'll figure out what that something is. Same equation, just rewritten a different way. Okay? They're going to be equal to each other, written a different way. One of the reasons it's important is if you have a TI calculator and you've ever gone to use the graphing feature. So anybody in that situation, do they have a TI 84, 83, that kind of calculator? Right? Okay, Kirsten has one. So if you go to graph, then the way that you graph in a TI 82, 83, 84 calculator is that all of your formulas have to be in this format. They have to say y equals some kind of equation. Okay? In a TI calculator, you can't type in 9y minus 4x equals negative 30 and hit graph and it graphs it. You have to have y equals something. So that's just kind of like a housekeeping-y kind of reason for it. The math reason why we need to be able to convert equations into some y equals form is that, and we're going to talk about this in chapter 2, is that what you put into the equation is usually x, and that's your input or your domain, and what you usually get out of your equation is y. Okay, this is what you get out. So like a silly example is I could have a function of, let's see, well, not even silly, just a simple example is I could have a function that tells me for how many hours I work, how much money I make, right? So let's say I have, well, yeah. So say you make $10 an hour. That'd be awesome, right? Make $10 an hour, and this is the number of hours you work. Okay, so if you have $10 an hour times X number of hours, you get how much money you make out of it, right? So when it's written in a format like this, it's much easier to vary the number of hours that I work and see how that affects how much money I make when it's in a y equals format, right? Versus if it was in the format that looked like this, then it's harder to tell. I mean, I still have some number X that I put in, and I have some number Y that I get out, but it's not in a really clear formula how I do that. So I just gave you, a 4 or 5 minute explanation about why this is important. You may or might be interested in why it's important, but it is important to know how to basically we're rewriting these equations to make them say y equals something, okay? We could rewrite it in any way, but typically it's going to be y equals something. All right, have I convinced you why it's very exciting to, or at least important to know how to do this skill? As much as I can convince you this Wednesday morning, right? So now let's talk about how we actually do this, okay? Oops, sorry. I haven't figured out the best way to erase all the time yet. All right, so sometimes writing our equations as y equals something is pretty straightforward. And that's where we're going to start off. We're going to start off with some equations that are pretty straightforward. So for this one, we have, nope, that's a G. We have 9y minus 4x equals negative 30. And we want it to be in the form of y equals something. Now, I know over here I have x equals 8. We're going to wait to plug that in because what we want to be able to do is we want to be able to put in any x and easily figure out what our y is. Okay, so if I want to make this y equals, basically I'm trying to get y by itself, right? So I'm going to do a lot of the same things that I would do when I was solving equations. I just now have two variables instead of one variable. Okay, so let's see here. Looking for my pen that I can write on my screen. So anybody, while I'm looking for my pen here, can anybody tell me what they think they would do first if you want to get y by itself? You can tell me, you can put it in the chat. You guys still here? All right, so I want to get y by itself, right? So what I'm going to do is I want to I want to move this 4x term to the other side of my equation. All right, so right now I'm subtracting 4x, so I do want to add 4x to both sides of my equation. Okay, and remember I'm allowed to do that as long as by the addition property of equality, right? I can add both sides as long as I'm adding it to both sides and I'm keeping balance. I'm allowed to do that. So then I'm left over with, I really want to write G, 9y equals 4x minus 30. Okay. So I'm almost there. I want to get y by itself. Right now, y is being multiplied by 9. So I actually need to divide by 9. And if I'm going to divide this term by 9, I also have to divide this term by 9, and I have to divide this term by 9. So these cancel out, and I'm left with y equals 4/9 x minus 30 over 9. Yay, fractions, right? Here we go. All right, so this equation and this original equation up here should be equal to each other, right? All I did is I converted the way that it's written, and they are equal to each other. But every time you're doing this conversion, they should be equal to each other. Okay, everybody tracking along so far? Everybody's quiet today.
Yeah.
All right, cool. All right, so now if I tell you, well, x equals 8. So tell me what happens when x equals 8. Okay. I should be able to plug x equals 8 into this equation or this equation and get the same solution for y. And you'll actually see that this equation is easier to work with. Okay, so this is my rewritten equation. And if I want to figure out what y is when x equals 8, then I just plug it in, right? Y equals 4. Oh, sorry, my clicking today. Y equals 4 times 8 divided by 9. I gotta get something better to write on here, sorry. Let's see. Ah, that's much better. There's some crazy looking numbers, right? All right, here we go. 4 times 8 divided by 9 minus 30 divided by 9. So 4 times 8 is 32. This is reviewing our fraction rules too, right? 32 over 9 minus 30 over 9. Does anybody know what that is? Remember, if the denominators are the same, you just subtract the numerators. So it's 32 minus 30, which is 2. And then the denominator stays the same, which is 9. So when x equals 8, right, y equals 2/9. I'm just going to kind of be sloppy about it like that, just so you don't have to watch me write that. Okay. This equation, how we have rewritten it, is way easier to solve than this equation. So I'm not going to do the whole process, but if I did this, I would have 9 times y minus 4 times 8 equals -30. Okay, and then I would have to evaluate and subtract and divide and do all of these steps. Instead, I can just plug in. Okay, so then this one takes a little bit longer. So for one variable, it doesn't seem like that big of a deal. But if all of a sudden I gave you a problem and I said, okay, well, 9y minus 4x equals -30, right? Tell me what y is when x equals, tell me what y is when x equals 8. Tell me what y is when x equals 10. Tell me what y is when x equals 20. Like if I gave you a set of data, you definitely want to convert your equation to a y equals equation because that's much easier to solve. You've already done all of those steps of solving for y in one swoop. So now you're just ready to plug in x and find the value. So hopefully now I've convinced you how awesome it is, right? Converting to rewriting formulas is awesome. Yay! All right, so now I've explained why it's important to solve for y. I want to introduce something else that for the people that have been in class with me before, you've probably seen it, not a whole lot, but in Algebra 2, we're going to use graphing tools a lot in Algebra 2. So in Algebra 1, you started to learn about graphing. In Algebra 2, we're going to use graphing tools a lot. And when I say graphing tools, I'm talking about either a TI 82, 83 calculator, some other graphing calculator, handheld graphing calculator, or there are some apps and websites that let you do graphing. Now you might be saying to yourself, okay, Mrs. Ross, you were just talking about rewriting formulas and now you're talking about graphing. What do they have to do with each other? Well, any equation can be graphed. And graphs are actually really powerful and really helpful when it comes to mathematics and visualizing what you're doing. And like I said, in Algebra 2, we're going to be doing a lot of graphing. So we're going to be solving equations, and then we're going to be converting that to graphs. So how do I want to ask this? Has everybody graphed with a graphing tool before?
Yeah.
Okay. If you haven't, it's okay. We're going to become familiar with this. But I just want to show you something, especially since we're online, it's easier to visualize. So what I want to show you is a graphing tool that I use a lot, especially online, because it's easy to share. And it's called Desmos. And it actually does relate to what we're talking about. So I'll loop back to that. So like I said, if you've had me in class before, you've heard of Desmos. Desmos is an online graphing tool. Okay, there is also, I think it's down here. Yes, there's apps. If you have Apple or Android, there's a Desmos app that you can have, and it performs a lot of the same functions that a TI calculator does. All right, but it's free. TI costs more money, and we can talk about this later. I don't think I talked with this class, but you cannot use a tool like Desmos on your ACT or SAT. So it's not the perfect tool, but it's a really good tool to help us visualize. Okay, so what these kind of tools do is they allow you to, okay, hit start graphing here. Maybe it'll work. Is what they do is they allow you to graph equations just like you would use a graphing calculator to do. And if you have one of those TI calculators, make sure you bring it to class and I'm happy to help you with it. And you might actually want to do both, right? You might want to have a graphing, you might want to, if you have a graphing calculator, you might want to try to use both when you can. So let's go back to what we were doing. So I said it actually does relate to what we were doing, right? We just converted 9y minus 4x equals negative 30 to y equals 4/9 x minus 30 over 9. So what I'm going to do is I'm going to graph this equation in Desmos. So I just want to introduce this tool so you can see it. So over here on the left-hand side, there's a box where you can enter in equations to graph. You can enter a really easy equation like y equals x, and you can see the line for that automatically shows up, right? But we solved and we got that y equals 4 divided by 9 times x, right? Minus 30 divided by 9. And that's what, right? Just making sure. Where's that paper at? Yes. 4 divided by 9 times x minus 30 divided by 9. Okay. So I know we're going off the path a little bit, but this is going to be an important introduction for the whole class. So what we've done is we've graphed the equation that we just solved y for. If you have a TI calculator, and I wish I had, oh, here, Google can help us out. TI 83 calculator. And these guys are not cheap. So that's the downside of the TI calculator. Okay. If you have a TI calculator, it's not that one. It's one of these. And there's different versions. They are all kind of the same. If you wanted to do this, oh, I wish I could zoom in a little bit. You could buy it at Walmart. No. If you want to do this, well, up here in the top left corner of your calculator, any of your TI calculators, there's a little y equals button. So if you go into this y equals button and you type this formula, and then you hit over here the graph button, then it will also do the same thing that Desmos does. Okay, so I just wanted to mention that. And again, I teach both ways. So I teach using Desmos as a tool because it's easy to share online, but I also want to teach you to use a graphing calculator if that's what you decide with your family that you need. Okay. All right. So I know it's wondering a little bit, but I promise it's all going to come together. So if you remember, we tried to find out what is the value, right? What is the value of y when x equals 8? So one way we can find that is to go to our graph and find out where 8 is, which is 5, 6, 7, 8. And we can actually look at our graph, and you can do this on your graphing calculator and say, okay, when when x equals 8, y equals 0.2222 repeating. And actually, if you do, we found that it was 2 divided by 9, right? Which is 0.2222 repeating. So one way, this is another way that you can look at data, and this is why graphing is so important. It helps you out. Another thing that Desmos does really well, and your graphing calculator does really well, is that you can turn any equation into a table. Okay. So if you remember, we said we wanted to know when x equals 8, what is the value of y? The value of y is 0.222222, which is 2/9. Okay. If you have a TI calculator, I wish I could make this bigger. Oh, here we go. So here's your Does not want to leave that picture up. There you go. There's your y equals where you equal your formula. You hit this graph button if you want to show the graph. If you want to show that table that I just showed you, you actually hit the second button, which means the second function, and hit graph because above that is a table function. Okay? So I just want to introduce that. One last thing. I promise. Okay. One last thing. This is the one thing that Desmos does that that your TI can't do currently. So Desmos actually lets you write equations in any order. So remember way back when we started this problem, you're like, we've been doing this problem for a long time, right? When we started this problem, we had 9y minus 4x equals negative 30. So in Desmos, we actually can write it in that format. So 9y minus 4x equals negative 30. Okay. Before I show that, if I did my algebra correctly, when I changed my first equation to my first version of the equation to my second version of the equation, if I did my algebra right, then these two should be the same line. Does that make sense to everybody? My original equation, right, should be the same as the equation that I wrote in a different format. They mean the same things, they're just written in a different way that's more useful. So another way that I can look at this and check is if I turn both of my equations on and visible, then they should basically overlap each other, which it's hard to tell because the purple is going over top of the red. But if I switch my equations here, right, we can see that these represent the same line. Okay, did I totally confuse you guys, or did that make a little bit of sense? Like, it's important to know how to rewrite equations for lots of different reasons, right? We have to be able to do that if we want to use our TI calculator. We have to be able to do that if we want to vary the variable, okay? And then we have these tools that we're going to be using a lot, and this is kind of one of the introductions to that. And the last thing to note is that however you rewrite your formula, it should still be equivalent to the original formula. Okay. How do you guys feel about that? Okay, confused? Kind of get it?
Pretty good.
Pretty good?
Yeah.
Okay. Anybody else? You guys good?
Yeah.
All right, awesome. Okay, so that is, when you do your homework, that's problem 7 through 15 odd, is you're going to be solving your equation for y and then find the value of y for the given value of x. So basically, you're going to be doing this, okay? You can check your work when you rewrite your equation by substituting the value into both equations, by graphing both equations and see if they match up. There's several different ways that you can check your work, okay? Then we get into a couple more problems at the end that are a little bit more tricky, stretch our brain a little bit. So I want to make sure that we go over these because you might see something like this. So I want you to be comfortable solving this type of equation. So does everyone think that they could solve this kind of equation? Or do you feel like you need another example?
Probably another example.
Another example? Awesome. I can do that. Okay. Let's do number... Well, this was number 14 from your book. Let's do number 12 from your book. I know it's not one of your homework problems, but let's go ahead and do it.
I still don't have my book.
Oh, did you get my email?
Yeah, but the thing is, they don't have any of the problems. They just have like like the pages that like kind of describe what you're doing?
They should have all the problems on there. I can send over the right pages for you.
Cool.
Yeah. All right.
Yeah,
So,
my actual
okay.
book doesn't get here until October 3rd.
Oh, yeah. Can't
Yeah.
wait to do homework till then.
Yeah.
Okay. So let's do number 10. Okay. This is on page 30 if you have your book, and this is in section 1.4. So we have 15x plus 4y equals 9. And we'll worry about solving for when they tell us when x equals -3, but we'll worry about that later. So let's rewrite this equation, and we want to rewrite it, solve the equation for y. That's what I should have been saying. We want to solve the equation for y. Okay, so we want to make it y equals something. Okay, so in order to make it y equals something, we need to kind of move everything else that's not y to the other side of the equation. Okay, so the first thing that I'm going to tackle is this 15x over there because it's a term all by itself. So I can subtract 15x from both sides of my equation, right? And that's going to leave me with 4y equals 9 minus 15x. Okay. All right. So I got that. Now, I still have y is being multiplied by 4. So in order to basically undo the fact that y is being multiplied by 4, I want to divide everything by 4. Okay, because if I have 4 divided by 4, then that's just going to give me 1. I also have to divide everything on this side of the equation by 4 as well. Okay, another way that you might have done this in algebra, this is like a side note, is that you could also multiply multiply by the reciprocal. So another way that you might have done this is to multiply by the reciprocal, and the reciprocal of 4 is 1 over 4. So basically you end up with the same effect, but if you're like, oh, why is she just dividing by 4? You can divide by 4 because that's the opposite of multiplying. You can also multiply by the reciprocal. Those are both okay ways to do that. You end up at the same spot. Okay, so let me go ahead and simplify this. I get y equals 9/4 minus 15/4 over x, or 15/4 times x. Okay, can I simplify any of these fractions? Nope, I can't simplify any of those fractions. Okay, so this is the equation solved for y. It is the same equation as 15x plus 4y equals 9. These two equations equal each other, right? This equation and this equation, they are the same equation. They're just written two different ways. Okay, they're equivalent equations to each other. They mean the same thing. They're just written in two different ways. Okay. So then the last step of this is I want to find out what happens if x equals -3. So in order to do that, I'm just going to plug in -3 and solve. Okay. I'm not going to do that because that'll take just a little bit, like a long time. But if you try that and you don't get the right answer, let me know. But that's how I'll do that. Okay, just to kind of loop back around to all the different things that we did. If I go into Desmos and I graph each of these equations, I should end up with two graphs that look the same because these are equivalent equations. Okay, oops. Okay, too many windows. I gotta get over here without closing anything. Back over here. Okay, so my first equation that I had was 15x plus 4y equals 9, right? That's my first equation. And then I said my equivalent equation is y equals 9 divided by 4 minus 15 divided by 4 times x. Okay. So you can see when you type in that equation, this one's on top, they're equivalent equations. They graph in the same way. Okay, and then we could also estimate when x equals -3, which is up here somewhere. If I can get my cursor to the right spot. If you're using a TI calculator, you can use the trace feature to do this. Okay. My hand is not that steady. There we go. It looks like when x equals -3, y equals 13.5. So you should get 13 and 1/2 if you're doing that. Okay. So then that's kind of the general idea. I have a couple more examples on your page, and these are a little bit more tricky. I will call these like the little bit more challenge problems. But I do want to talk about how we solve them. Just so you have a familiarity with them, and especially, like I said, I'm not trying to always bring this up, but if you are taking an ACT or SAT test, you do have to be able to convert to y equals if you want to use your graphing tool, and sometimes you might see a problem like this. Okay, so the first one up here, and we'll wrap up in about 10 minutes. So I want to kind of demonstrate how to do these, and I want you to try. Your homework is 21 through 25 odd, and then 29 and 31. So these are a little bit different. They are going to be a little more challenging, just kind of FYI. So example number 2, this is back to your notes. We have 5y plus 6xy equals 30. And I want to solve the equation for y. So I want to have y equals something. Okay, but what do you notice about this equation that's different than those other two that we just did? Well, I noticed that in my terms, I have a y here and a y here. So the idea of just getting y all by itself got a lot trickier. Right? So how are we going to do that? How are we going to get y by itself when it's in two different terms? Well, we get to use my favorite property to be able to do this. All right, which my favorite property is the distributive property, and this is kind of the reverse of the distributive property. So sometimes when you're solving these types of equations, you have to get a little bit creative, which is what we're going to have to do here. So we have 9y, I don't know why I want to write it like that, 9y plus 6xy equals 30, and I want to solve for y. Okay. What I do notice is I do have a y in each of these terms. So what if instead of trying to well, first of all, can I combine these two terms together? Are 9y and 6xy like terms? Can I add them together? Nope, right? They're not like terms. This one has an x in it, that one doesn't. So you're not allowed to add these together like they are, right? So now I have to be a little creative and say, well, each of these terms does have a y in it. So what if I pulled a y out of each of these terms? Okay, so what if I pulled a y out? It's like basically reverse distributive property, right? If I pull a y out, then I'm left over with, if I pull a y out of 9y, I'm left over with 9. right? And if I pull a y out of 6xy, I'm left over with 6x, and that equals 30. Okay, so this is kind of a creative way to get y by itself. Right now we have y by itself. It's y multiplied by something equals 30. Is everybody okay with how I went from this equation to this equation?
Yeah.
That makes sense?
Yeah.
Cool. Okay. So now how do I get y by itself? Well, this is y multiplied by 9 plus 6x. So I actually can divide out the second part. So if this was, 3 times y, we would just divide by 3. But instead of 3 times y, we have 9 plus 6x times y. So we're going to divide by 9 plus 6x. Okay, and if I divide this side of my equation by 9 plus 6x, what do I have to do to this side? Divide it by 9 plus 6x. Okay, these guys cancel out, and I'm left over with y equals 30 divided by 9 plus 6x. Now, can I simplify that any further? Nope, right? I can't really get this 9 plus 6 out of the denominator. I can't really move x to the numerator. It's okay that x is in the denominator. And this is an equivalent equation to my original equation. So if you go into graph each of these equations, they will be equal to each other. Okay. The second part is what happens when x equals -6. That's the pretty easy part that I'm going to let you guys do on your own. So that's, you just plug in x equals -6 here and solve. Okay. That look fun? Yay, right? So then let's, we have, about 5 minutes left. Let's try number 3 and number 4. Okay, so see if, I'll just start with a new one. Okay, so number 3 says I have 4x plus 7y plus 5xy equals 0. And then again, we'll plug in our x equals 1 later, right? So I want to rewrite this as y equals something. Solve for y. Okay, so again, I notice I have y in this 7y term, and I also have y in the 5xy term. Can I combine these two together? Can I add them together? Nope, right? I can't do that. I also have a third term over here, which is 4x. That doesn't have a y in it, so that one's pretty good. I could just kind of leave that alone. So in order to solve this, what I'm going to do, first I got to write my equation, 4x plus 7y plus 5xy equals 0, right? So the first thing I'm going to do is I'm going to subtract 4x from both sides because there's no y in it, so that's completely fine. If that goes to my other side of my equation, I can kind of kick that out and I'm good to go, right? So I have 7y plus 5xy equals -4x. All right, so now what am I going to do? How am I going to get these y's together and out of these terms? I'm going to do the same thing I did in the last problem, right? I'm going to pull a y out of each one. And if I pull a y out of 7y, I'm just left over with 7. Okay. If I pull a y out of 5xy, I'm left over with 5x. And that still equals negative 4x. Are you guys okay with us pulling this y out? So total side note, if I took this, what I just did, and I'll erase this, right? If I took this and I distributed my y, I would end up with 7y plus 5xy, right? So, and that's what I originally had. So just kind of proving that that's true. All right, so my last step then is to get y all by itself, and I'm going to do that by dividing both sides by what y is being multiplied by. So y is being multiplied by 7 plus 5x. So I'm going to divide by 7 plus yx, but if I do that to the left-hand side, I have to also do that to the right-hand side. Okay, these cross off, and then we get, again, for the sake of you guys not watching me write painfully slow, we get y equals negative 4x divided by 7 plus 5x. And again, this is an equivalent equation to my original equation up here. Okay? Very exciting, right? Woohoo! Any questions on that? Now, there's two last problems on there. There are, and if you look at your homework problems, so these last two examples are similar to problems 21 through 25 on. Okay, there's problems 29 and 31 that I have on there, and I would consider these kind of like bonus problems. Okay, so these are a little bit more tricky, well, a lot more tricky to do. I want you to try them out. Try to figure out how to solve 29 and 31. And if you get stuck on them, just bring them to class on Monday and we can talk about them. Okay, I will, with my 1 minute left, I will give you a hint how to solve this one from your homework. And maybe that will help you with 29 and 31. Okay, so example 4 says I have 1 over x plus 1 over y equals 1, and to solve for y. Okay, so how you would do this is you're going to look at the denominators and you're going to multiply by the lowest common denominator. And the lowest common denominator of x and y is x times y. Okay, and then you're going to multiply that by your left-hand side of your equation. And you're going to multiply that by the right-hand side of the equation. Okay. And then once you do that, you have to distribute this, multiply it out. Okay. And you end up, and I'm skipping a few steps here because I know we're out of time. You end up with y plus x equals xy. And then from here, see if you can figure out how to solve for y. So that's kind of the hint for how to solve number 31. Okay. Again, try out those two. I know we didn't go over a whole lot, but just try them. They're good. They're good, like brain stretching kind of problems. So homework. So by Monday, you should have done definitely 1.1. That was last week. So 1.2, 1.3, and 1.4. And then on Monday, we'll start with 1.5. Okay.
Thanks.
Thanks, guys. And then just to give you guys a heads up, we will probably finish chapter 1 next week. So, so kind of have that on your, I know we just started, right? It feels like we just started, but we'll finish up chapter 1 next week. And, yeah, that's kind of where we're at. There's 3 more sections left.
Okay. Thank
All right.
you.
Have a great weekend, guys.
You too.
All right. Thanks for coming. Bye.
Bye.
And let me know if you have any questions.
Okay, thanks.
Thanks.
I'll keep looking at the links you sent
Yeah,
me.
so
Maybe
like
I'll find
Sophia,
something.
the one that says like when you want to do homework, here I'll stop the broadcast.
Yeah,